All right, so we're going to discuss the nomenclature of cyclic alkanes now. So a cyclic alkane is if we take our alkane and we connect it in a cyclic structure. All right, and again, focusing on nomenclature of these cyclic alkanes, the first step is to find the parent chain. So I've updated our rules. We're going to find the parent chain, the longest continuous set of carbons. And for cyclic alkanes, it's particularly easy to find the parent chain because the ring is always going to be the parent chain in that molecule. All right. Now, truthfully, that's not always the case every single time, but I'm going to pick my battles here. And for our purposes in this course, anytime you see a cyclic structure, a ring in your molecule, that ring will be the parent chain. And how we're going to name that parent chain is we're going to stick this prefix cyclo on there. Then we're going to use those same number of carbon prefixes that we discussed previously for alkanes, 1 meth, 2 eth, etc., etc. And then we're going to follow it up with that suffix ane, just like we did for alkanes. So going through these examples here, we have 1, 2, 3, 4, 5 carbons. This would then be cyclopentane. All right. This example here, probably the most famous of all of them, one that we'll talk a lot about in this course. 6 carbons making this cyclohexane. All right, for this one here, we got to count 1, 2, 3, 4, 5, 6, 7, 8 carbons. This will be cyclooctane. And our little triangle here means that we only have 3 carbons, or cyclopropane. All right. So if we see a ring, that ring is our parent chain. We may name our parent chain with that prefix cyclo, the number of carbons, and then that ane ending. All right, so what if we stick some substituents on there? Okay, so again, let's focus on this first one. Our parent chain is always that ring. So these 6 carbons here, I know my parent chain is a cyclohexane. And then this would then be an alkyl substituent, a methyl group. In fact, you'll notice that in our notes here, I didn't have to add anything new to step 2. We're just going to find and name our substituents. All right, those alkyl substituents will have that YL ending. I guess we can also add, we do have those branched alkyl groups that we now know how to name too. Okay, so then we're going to number our parent chain. And this step I'm actually not going to add anything to either, but I do want to re-emphasize what our goal is to have the smallest possible number in the name. And this is what's going to make cyclic alkanes different from straight chain alkanes, is we can start numbering at any carbon we want. There's not one end or the other like there is with a straight chain alkane. So then we're going to put that substituent, that methyl substituent, on the lowest possible number. We're going to give it carbon 1. All right. However, if I moved it, for example, let's say that I pick up this methyl group and I move it over here. What's that going to do to my numbering? Well, all I'm going to do is I'm not going to call this carbon 1 anymore. I'm going to call this carbon 1. Right? No matter where I put that methyl group will be on carbon 1. So when we assemble the name for our mono substitute, meaning there's only one substituent on there, cyclic alkanes, we actually don't include the locant. We already know where it is. It's on carbon 1. So rather than saying 1 methyl cyclohexane, we would just identify, let's go back actually. Identify this methyl group on carbon 1 as methyl cyclohexane. We don't build that locant into the name. All right, so these two, same examples. Let's see. So my ring is always my parent chain. And this is a good example of what I mean by the ring is always the parent chain. Because this substituent right over here, this alkyl group, is actually larger than that ring. Doesn't matter. The ring is still the parent chain. Right? So then this 1, 2, 3, 4, 5, 6 carbon alkyl substituent is a hexyl group. Again, that's carbon 1, but I'm not going to bother putting that in the name. The name of this molecule here is hexyl cyclopentane. All right, over here again, our ring is our parent chain, our cyclobutane. This is one of our branched alkyl groups here. All right, so I could either ask you for the common name of this molecule, this with this little fork at the end, but having a total of 3 carbons. This would be isopropyl cyclobutane. Or I could ask you for this molecule's IUPAC name, in which case we got to go through that process. We're going to shrink down here and look at this branched alkyl group. Remember, this carbon right here bound to that parent chain is always carbon 1. And I'm going to find the longest continuous set of carbons to be my fake parent. So that means this 2-carbon group right here is my fake parent. And this thing coming off of it is my fake methyl substituent off of carbon 1. Let me choose a different color, actually. All right. Well, my fake parent is 2 carbons long, but since it's fake, it's not an ethane, but an ethyl group with a carbon coming off of carbon 1. So the IUPAC name here would be, in parentheses, 1-methyl ethyl cyclobutane. All right, so then what happens if we have multiple substituents? All right, again, my parent chain, these 5 carbons. But now that I have multiple substituents, I do have to indicate how far apart they are on this ring by using our locants, by using our numbering scheme, right? So this is a 1,3-dipropyl cyclopentane. And that's important because there's also a 1,2-dipropyl cyclopentane, and that's a different molecule, right? So we have to include those locants in our name. 1,3-dipropyl cyclopentane. Okay, over here, we're going to do our parent chain. 1, 2, 3, 4, 5, 6 carbons. We have this 2-carbon ethyl group on there. And we have this 4-carbon butyl group on there. All right. Now, since this is a ring, we're always going to start at one of our substituents, but I could actually number this ring in 2 ways, and I would get 2 different answers. All right, is the ethyl group on carbon 1 or carbon 3? Well, if we look at our 2 numbering schemes, the red numbering scheme is a 1 and a 3, and the blue numbering scheme is a 1 and a 3. So that's a tie. And how do we break our tie? Just as before, when we number our parent chain, if we have a tie, we default to alphabetical order to break that tie, right? It's the same rule as we applied before. It's going to be quite common with these di-substituted rings that we have to break a tie here. Butyl comes first in alphabetical order. So this molecule here would be 1-butyl. 3-ethyl cyclohexane. All right, so two more examples here. Let's do this one. I'm going to find my parent chain. 1, 2, 3, 4, 5, 6, 7. All right, so this would be a cycloheptane. And I have these three substituents, an ethyl group, another ethyl group, and a methyl group. All right, so now the numbering of our parent chain. The thing about rings that's a pain in the butt is that you can start anywhere and you can go clockwise or counterclockwise. Your goal is, again, to put the lowest possible number in the name. All right, so I don't want to start here, 1, 2, 3, 4, 5, 6, 7, and have a 7 in the name. I want the lowest possible number. If we go this direction, 1, 2, 3, 4, that's a 1, a 3, and a 4 in the name. If I go the other direction, 1, 2, 3, 4, that's a 1, a 2, a 4 in the name. So I'm going to want to use that blue numbering scheme because I, again, want the lowest possible number in my name here. All right, so that means when we put this all in alphabetical order here, we have our 2,4 diethyl all right, remember we ignore the di, we're just looking at the E compared to the M. So the dimethyl is going to come, diethyl is going to come first, and then we have our 1 methyl cycloheptane. All right, so remember the lowest number in the name. What makes rings tricky is we can start at any one of those substituents as carbon 1 and then number clockwise or counterclockwise. All right, so this one too, and if you have not been, it's a good idea to pause and try to do it on your own. Okay, but for this one here, with another 3 substituents, I could start here, go clockwise or clockwise or counterclockwise. That'd be one numbering scheme. Here, 3, 4, here, 5, 6. So there's like 6 different ways that you could number this thing. And if you're having trouble seeing the correct one, it's a good idea to just start listing them. All right. My ring is going to be 1, 2, 3, 4, 5, 6, 7, 8 carbons. So I know my parent chain is a cyclooctane. Can identify our substituents, a pentyl, a methyl, and a propyl. All right. So what we want to note is that these two are the closest. So we're going to start numbering 1, 2, 3, 4, 5, 6, 7, 8. Or we can go the other way, 1, 2, 3, 4, 5, 6, 7, 8. So those two being the closest is a good starting point because I want the lowest numbers in the name. In both cases, I would have a 1 and a 3. And in both cases, I would also have a 6. So this is where we're going to break our tie using alphabetical order. All right. I'm going to choose to put the methyl group on carbon 1 because that beats putting the pentyl group on carbon 1 based on alphabetical order. So we're going to use our red numbering scheme for this particular ring. You can convince yourself that if you started here and went this direction first, you'd get a bigger number. If you started here and went this direction first, you'd get a bigger number. And if you started here and went either direction, you'd get a bigger number. These are the smallest possible numbers that we could have in our name, And again, we had a tie, so we had to break that tie with alphabetical order. All right, so this would be 1-methyl. Okay, 3 comes next, or rather, pentyl comes next in alphabetical order. 3-pentyl, 6-propyl, cyclooctane. Cool. So we have these new additions to our rules on our nomenclature. Most notably, our cycloalkanes. When we find our parent chain, the cyclic alkanes, the ring is always going to be the parent chain. And to name those cyclic alkanes, we keep that same ane suffix, but we stick this cyclo prefix on the beginning. Nothing new about how we find or name our substituents. We still have our alkyl groups and our branched alkyl groups. When we number our parent chain, again, nothing new. We want the smallest possible number in the name. And should there be a tie, we're going to put them in alphabetical order. All right, when we assemble our name, we got to note we do have a new rule here for monosubstituted alkanes. They don't have that same format of locant substituent parent. Since we know the locant's always going to be 1, we just simply do not include the locant in the name. All right, and in lecture, we'll talk about this next step here, the stereochemistry that goes at the beginning of the name.